is a north-seeking device. It is also known as magnetic compass, standby compass, or directly reading compass. The purpose of this compass is installed in aircraft is to indicate the aircraft heading with respect to magnetic north. Heading means where is the north of the aircraft is facing. Inside the compass, it has magnets. So the magnet attracts to the Earth magnetic field. Our Earth has its own permanent magnets. So our pole permanent magnet is opposite from our pole, which means if our compass shown north, it means Earth permanent magnet is south, because north will attract it to south. This compass is a self-contained instrument. This compass is the most familiar compass type that is used. Inside the compass, there is a freely suspended bar magnet that one of its end is pointing to the magnetic north. The compass casing will move according to the aircraft direction, but the compass remains stationary, and new heading will be viewed on the compass, which will be read by the pilot. So the compass has the Lubber line, which is to reduce the parallax error, and Lubber line is also used to read the reading. A compass card or float is mounted on jeweled bearing. It has numbers and direction markings so that magnetic heading of the aircraft can be read from the instrument. The case is filled with light oil. The compass card or float that mounted on jeweled bearing is also inside the compass case, and inside the case it is filled with light oil, which is white kerosene, which will float the card and lubricate the bearing. There is also two compensating permanent magnet installed under the compass to adjust the compass for deviation error. There is two compensating permanent magnet installed, which is one with face north and south, another one with face west and east. Okay, this is the Lubber line. The Lubber line is used to read the readings and to reduce the parallax error. This is the compass case, and inside this compass case has the white kerosene. The white kerosene is filled in here, and this expansion unit will contract when temperature is high. When temperature is high, the white kerosene inside this case will expand due to the temperature. So when the white kerosene the liquid is expand, it needs more space in there to avoid bubbles. So this expansion unit will contract to let the liquid spread. Then when the altitude is high, the temperature is low, so this expansion unit will back to its normal size, because in the white kerosene inside the compass case has contract. So this is the compensating magnet, the compensating permanent magnet. that have two, which one is faced to the north and south and one is to the west and east. This is the card that will show the reading, and it is floating inside here. It's float freely. There is no bolt or any attachment between card and this holder.
Okay, so we move to remote indicating compass. This compass is a heading indicator. So the pictorial navigation indicator is normally referred to horizontal. This compass is not a self-contained device, which is it needs external source to operate. Another name for this compass is gyro compass and slave compass. Heading information is left to the flat valve or directional gyro for this compass. So this compass is sense the Earth's magnetic field. Okay, the Earth's magnetic field will be sent in two conditions. First, when a magnet aligns with them, so it will sense the Earth magnetic field. Second, when an electrical current is induced or generated in any wire cross of them, so the Earth magnetic field will be sent by this compass. Okay, this compass have two operational modes, which is slave mode and free mode. For the slave mode, it will operate automatically and will operate when magnetic heading reference is reliable. So directional gyro will slave the magnetic flux detector. So it will supply long-term magnetic to correct the apparent drift. For the free mode, it will use reverse mode. This mode will be used when the magnetic heading reference is not reliable. For this mode, we have push button there, so we can push where the mode we want. So this is all the components that have in this compass. Okay, first we have flat valve or floodgates. We call it flat valve or floodgates. These flood usually locate where there is least interference of magnetic deviation. So there is flood valve. This flood valve is sense the direction of the Earth's magnetic field. This flood valve use pendular suspension system, allowing freedom 25 degree in pitch and roll to sense the direction of the Earth. Okay, this flood valve is sealed and liquid dampened to prevent oscillation. Okay, so who provide the heading signal for the compass? So directional gyro unit will provide heading signal to the compass system based on gyroscopic rigidity. Okay, what is the function of slaving amplifier? Okay, this slaving amplifier is to slave the directional gyro to the flood valve when it is in compass mode, which is slave mode. So slaving amplifier is needed at the slave mode. This slaving amplifier consists of self-synchronous transmission system and torque motor in the gyro unit. Receiver rotor sense misalignment and the error signal is fed to the slaving amplifier, and torque motor, which is applies a force to the appropriate gyro gimbal. So you can see it at the picture above. So another amplifier in this compass is servo amplifier. This servo amplifier is to detect any error and feed to servo network to balance the circuit. So any error in this compass will be detected with servo amplifier. So heading indicator, we can see it at the mount on the instrument panel. So we can see heading indicator there. So next we have compass controller. This compass controller is a mode selector switch, which is DG or slave. So it is annunciator. It show when the system is synchronized. So next set heading knob is set heading knob ni we can set it manually using our hand. Okay, next we move to horizontal situation indicator. So this indicator is also known as course deviation indicator, or the short name for this indicator is CDI. Okay, what is horizontal situation indicator? This indicator is a combination of heading, slab or gyro indicator with VOR glide slope indicator. So the combination of this indicator will represent horizontal situation indicator. This horizontal situation indicator is represent aircraft heading and aircraft position. At this indicator, we can see it have this symbol which is represent heading bar. For this symbol that pointed here is a course bar, and NAV and HDG is a flag. This flag will be appear when the indicator is failed. The system is failed in this indicator, so the flag uh, will warn us that to tell that the system is failed. So usually this flag is a warning flag. So this is all the component that I have in this indicator, as you can see at this slide.
Hi sir, today I'm gonna present my subpart in topic standby compass and its swing procedure. The first one is radio magnetic indicator or RMI. RMI is display magnetic heading and bearing indication in a single indicator. Heading information is from slab compass system, ADF, and VOR is from airfield non-directional beacon or NDB. ADF will show direction to and from of the designated airfield. VOR will show the exact heading of the designated airfield. This is the pictures of deviation indicator and bearing distance heading indicator. So the next one is aircraft magnetism and its effect on compasses. There are two types of magnetism in aircraft. The first one is hard iron magnetism. It is of permanent nature and builds itself into the aircraft structure during manufacture. The second one is soft iron magnetism. It is of a temporary nature where the earth feels magnetism some materials. This is very dependent on aircraft heading, altitude, and its geographic position at any particular point in time. And the next one is compass and compensation definitions. Let's go to the first one is calibration, means the measurement of residual deviation of a compass installed in an aircraft. Compensation means the correction of deviation resulting from magnetism in an aircraft. Deviation means an angle required to be added algebraically to a compass reading to obtain the aircraft magnetic heading. So the next one is direct reading compass, means a compass which had a magnetic sensing element and heading indication located in the one instrument. Next, remote indicating compass means a compass system which had the magnetic sensing element located remotely from the indicators together with gyroscopic means to stabilize or smooth the heading indicator. The last one is standby compass, means a direct reading compass which is not used as a primary heading reference. So this is all of my subpart. Thank you.
Aircraft error. Aircraft error is error that took place in aircraft itself that generates a magnetic field and disturbs the precision of the compass system. Due to the fact that aircraft has certain amount of iron, magnetic material and a lot of live wire. This aircraft error are also known as static error divided into three categories: index error, one cycle error, and two cycle error. Principal error on compasses. Index error. It is a coefficient A error results from the alignment of flux detector unit and has the same magnitude on all headings. On one-cycle error, these are the deviations produced as a result of the effect of components of hard iron magnetism of the aircraft structure, coefficient C and B error. Two-cycle error is result from imperfection in the transmission of heading data and are often known as transmission error. They are caused by the impedance or voltage unbalance in the flux detector sensing element or in the synchros of the compass system. Another source of two-cycle error is soft iron magnetism. Crosstalk error. Crosstalk error is error that occurs particularly during electrical swinging procedure when DC signals simulating the earth field are applied. They are caused by different sensitivities of the flux detector unit coil and by unequal air gaps separating the flux collector horns. The overall effect is to produce quadrilateral components which offset the field from that original intended. Compass swing. Compass swing is a process of swinging and compensating a ship or aircraft compass by determining and reducing the deviation coefficient and recording the residual deviation. Swinging the compass means observing the compass reading on a different heading and compare the magnetic heading of the aircraft with the compass reading. Step to determine compass deviation is calculating the deviation error and determining coefficients, neutralizing the magnetic field of the aircraft by adjusting the compensator device, recording any residual deviation. Deviation recorded on the steer-by curve must not be more than 5 for light aircraft, 3 for large aircraft. Deviation cut should be in interval of 30 degrees on light aircraft and 45 degrees for large aircraft. Conditions that require compass swing. There are many conditions that are required compass swing, such as after flying through electrical storm or struck by lightning, after modification, repair or major component change involving magnetic material, calendar due date, suspect error reading, after modification in the vicinity of flux detector, electrical or radio installation in vicinity of flux detector, whenever a compass been subject to shock, after magnetic crack detection check, after varying freight load of magnetic influence, aircraft has been in long-term storage, whenever the sphere of operation of the aircraft is changed to one of different magnetic latitude.
So, for the type of swinging procedure, they have three types, which is conventional, electrical, and inertial navigation system (INS). So, for the conventional, the term conventional to signifies a procedure in which the magnetic heading reference datum is obtained, either from the compass base with the heading alignment marks painted on it or from a datum compass. Next is the electrical swinging procedure is one in which the Earth's magnetic field is simulated by an electrical signal in such a way that it is unnecessary to rotate the aircraft onto the various headings as in the conventional form of swinging. And next is the inertial navigation system (INS). This is used the system display unit heading information as the datum for the compass swinging. So, the defect of diurnal change in magnetic variation must be taken into account in order to minimize the compass deviation error. Next is preparation before swinging. So, a check should be made to see that all airborne equipment is installed in aircraft. Then, loose item or tools made from the magnetic material should not be left in the aircraft or carried by the personnel engaged in a swinging procedure. And next is any detachable cockpit mechanical control locks which might be magnetic should be removed and placed in their flight stowage, where the towing arm and the towing vehicles are to be used for maneuvering the aircraft. Their possible magnetic effect should be investigated, and if significant, they should be disconnect and move clear before taking any the compass reading. So for the compass-based classification, they have a two class. The difference between these two class is limit permissible deviation. For the class 1, the maximum permissible deviation is plus minus 0.1 degrees. So best accuracy are required for carrying out refined swing. For example, swinging aircraft in which remote reading compasses are used as a magnetic heading reference system in conjunction with a size equipment as a Doppler system. And next for the class 2, the maximum possible deviation is plus minus 0.25. Base accuracy are suitable for carrying out standard swing. For example, swinging of aircraft in which the primary heading reference is provided by a remote reading compass system, which a direct reading compass servicing as a standby. Next is the compass swing procedure. For the compass swing procedure, make sure the datum compass should be aligned with the aircraft longitudinal axis at the distance of 50 until 150 feet. And then the sighting of the aircraft longitudinal axis is indicated by two plumb bobs suspended fore and aft of the fuselage. On the compass arrows, align the plumb bob with the marked line. Aircraft heading on the cardinal and quadrantal points offset by 5 degrees is allowed before taking a compass reading. Allow short pause between each heading and tap compass gently. Next, record all the reading on a proper record form. Adjust the coefficient CBA, the aviation card to be raised, detail of aircraft type and registration, compass type and series number, place and date to be recorded on the back. So compass swing to be recorded in need to be recorded in the aircraft logbook. So yeah, that's all from me. Thank you.